Hello guys, I'm Genius and you're welcome to my channel once again. In today's video, I'm going to be looking at equations of uniformly accelerated motion. I noticed that students actually find it difficult to solve problems on this topic, and that's why I've decided to make a video on this topic to help us. Are we together now? Who's calling me now that I'm making a YouTube video? What else is this? Please guys, excuse me. It's one of my students. Hello? Yes, last one. What is it? I'm making a video. Why are you calling me by this time now? What is it? You are finding it difficult to solve problems on dimension of physical quantities? Wait. Are you aware that I'm on YouTube now? You are not aware? Please, I'm on YouTube now and I've made a video on dimension. Please go to YouTube, search for my Junior Science Hub and make sure to subscribe to the channel so that anytime I post a video, you can actually be notified. Yes, please do that. What again? You can't solve problems on unit conversion. I just did a video on that as well. Please see, I'm making a video now. Please don't disturb me. Are you getting me? After now we'll talk. Okay, bye. Sorry. Bye. Oh, wow. Please, guys, I'm very sorry. Okay, to my students, you just needed me to help solve problems for her. That reminds me, just in case you've not subscribed to this channel, I would like you to quickly do that. Like the video, subscribe to the channel, and please share the video to your friends whom you think might find it useful. Are we together? Because Math Genius is here for you. Now let's quickly move into what we have today. Equations of uniformly accelerated motion. When we think about equations of uniformly accelerated motion, we're talking about the equations that will be used to calculate problems when a body or an object is said to undergo a uniform motion or is said to undergo a uniform accelerated motion. And so for us to fully understand these equations, we have to understand some terminologies that are associated with this topic. Are we together now? The first is motion. Is what? Motion. Are we together now? So the question is, what is motion? Motion is the change of the position of a body with respect to time. That is motion. The change of the position of a body with respect to time. So if you have a body, let's say a girl, a boy at this point A, if he changes his position from this point to this point, then we can say that this body have undergone motion because he has changed his position with time. That is what motion. And then talking about motion, we have what is called the parameters of motion. The what? The parameters of motion. When we talk about the parameters of motion, we're talking about those terms, those terminologies that are associated with motion. When an object or a body is said to move, what and what are involved in the motion? The first thing we look at is distance. Is what? Distance. All right. Now, distance, whenever an object or a body undergoes motion, we will see that that body or the object actually covers a distance. Are we together now? You can't move without covering a distance, and so distance is connected or related to motion. Connected to distance is displacement. They are the same thing. Okay, it's just that displacement is distance traveled in a specified direction, and to define distance, this distance is the measure of the separation between 2 points. Distance is the measure of separation between 2 points. The measure of separation between these 2 points A and B is smaller than that between these 2 points C and D. So the distance between C and D should be bigger than that of what? A and B, and that is what distance. While displacement is the distance traveled in a specified what? Direction. So when we talk about motion, we talk about distance or what? Displacement. They are one. And then another, that's number one. Then let me take number two. Then another parameter of motion is time. Is what? Time. Now, time is the measure of the duration of an event, and you know that anytime an object moves, it is with respect to time because we are on Earth, and everything is happening under time. Time is actually regulating everything, and so if an object moves, you're going to be taking into consideration the time taken for it to move, and so time is also a parameter of motion. So when we talk about motion, time must be included. Then number three is velocity. Velocity, all right, velocity or speed, they are the same thing, just that while one is traveled in a specified direction, the other isn't. And so velocity and speed are also measured. Are we together now? So when an object moves, we ought to take into consideration the speed with which the object moves with. The speed tells us how fast the motion of the object is. If the object moves faster, it now means that the object has a higher speed than an object that moves slower. Are we together now? And so when we consider the fastness, yeah, of the motion, we talk about speed. Now, why speed is without direction, velocity is with direction. And let me quickly bring about the topic or the terminology, scalar and vector. Now, anyone that has direction and magnitude is a vector. Are we together? So since distance is since displacement is the distance traveled in a specified direction, then displacement is a vector what quantity, while distance is a scalar quantity. I'll be dropping video on scalar and vector very soon. Are we together now? And speed is just the rate of change of distance with time. So speed is equal to distance over time. Are we together now? And so velocity is the speed traveled in a specified direction. So speed is a what? A scalar quantity, while velocity is a vector what? Quantity. Velocity v is equal to displacement. You can call it s anyway, all over what time. Are we following now? But they are also they mean the same thing under this topic. Are we following now? Because we are looking at mechanics here. Are we there? And mechanics is divided into two. We have kinematics and dynamics. And in kinematics, we are not actually interested in knowing what causes the object to move, but just trying to talk about the motion. Are we following now? And so the next thing in line that we're going to discuss when an object moves is acceleration. Is what? Acceleration. Now, I know most students don't understand acceleration, but acceleration is nothing too big. Acceleration is actually the change of velocity, yeah, with time. When velocity or speed changes with time, are we following now? Then the body is said to accelerate. For instance, if an object was stationary, was at rest, it was not moving, are we together now? And that object suddenly moves, the speed initially was zero because it was not moving, but the speed with which it now moves and arrive at a point becomes the final speed. So it now means the final velocity. I'm using speed and velocity interchangeably here because I'm not looking at dynamics. We are looking at kinematics. So, but to define acceleration, we strictly define acceleration as the change in what? Velocity, not speed. And so the velocity with which the object moves with becomes the final velocity, and that which it was, and that which it had initially becomes the initial velocity. And that brings me to tell us that velocity, we can have final velocity v and initial velocity u. Are we together now? Yes. And that is what? Velocity. Now, having said that, these are the parameters that we use for motion. When a body accelerates, it changes its velocity, and the change could either be increase or decrease. When a body increases its velocity, it has accelerated. When it decreases, it has also accelerated, but more specifically, it has decelerated, because when it decreases its velocity, it becomes deceleration, or what we call retardation. But when it increases its velocity, it becomes acceleration. Are we together now? So I think I have to go on to write the parameters very well out so that we can see what we have. So we are having number one is distance. In this equation, we're going to be calling distance s, and then we have number two, we have time t, then number three, we have velocity, or speed. But now, since velocity is of two types because of acceleration, we have final velocity, okay, final what? Velocity v, and then we have initial velocity what? U. Are we together now? Initial what? Velocity, and then finally we have acceleration. These are the parameters of motion, STVUA. Are we together now? All right. So if I want to restructure this, I can call it as 2VA. Stuva. Okay, that distance, time, initial velocity, final velocity, and acceleration. All right, so having said this, these are the things that you actually need to talk about equations of what? Uniformly accelerated motion, because these are the parameters that are found in the equations used to calculate uniformly accelerated motion. Before we move into the equations, because of this word uniform, we have to look at what uniform acceleration is. Are we there? And before we go into that, we have to look at uniform speed, uniform velocity, then before uniform acceleration. Are we there now? All right. So looking at uniform speed, uniform velocity, and uniform acceleration. So we're going to start with uniform speed. What do we mean by saying a body moves with uniform speed or is moving with uniform speed? Now you need to know that another word for uniform is constant. Okay. When we say uniform, we're talking about is constant. Are we together now? All right. Constant means not changing. So when we look at uniform speed, a body is said to move with uniform speed when it covers equal distances in equal time interval, no matter how small the time interval may be. That is uniform speed. A body is said to undergo uniform speed when it covers equal distances in equal time interval, no matter how small the time interval may be. Now, I have to explain that. Now, remember that speed, the fundamental formula of speed is equal to change the distance, right? That's distance all over what? All over time. All right. So let's now give a table showing the distance covered by an object and the time during which the distance is what is covered. Are we together now? Yes. So we have distance in meter, then we have time in seconds. Now we're going to start from when the body was at rest, 0 0. Let's say the body covers a distance of 2 meters in 1 second, then 4 in 2 seconds, then 6 in 3 seconds, then 8 in 4 seconds, and 10 in 5 seconds. So our idea is that we want to be getting the speed for each motion. Are we together now? To be more precise, speed is changing distance over time. To be more precise, yes, over change in time as well. Yeah. So to get the speed for the first motion, speed now is equal to, now for this one, it's going to be 2 minus 0, because change means final minus initial. 2 minus 0 over what? 1 minus 0. And for this one, okay, that's going to be, let's simplify this. That will give us what? 2 over 1. That's equal to 2. That's for the first motion. So it is 2 meters per seconds. And then for the next one, it's going to be what? 4 minus 2. All right, over 2 minus 1. That will give us 1 minus 2 is 2 over 1. Give us 2 meters per second. And if we do for the other ones, it's going to also be what? 6 minus 4 over 3 minus 2. That's 2 over 1. Give us 2 meters per second as well. So you can now see that since the speed is constant, is uniform, is not changing, the body whose motion, whose distance and time are being recorded in this table is said to be undergoing uniform speed, because it covers equal distances in equal time interval. That's between 0 and 1, it covers 2 meters. Between 1 and 2, it covers 2, another 2. Between 2 and 3, it covers another what? 2. So it's covering equal distances 2 2 in equal time interval 1 seconds. So in each seconds it's covering 2 distance, and so that is what we call uniform speed. And in the same way, talking about uniform velocity, the only thing we have to change is to change that this is no longer distance but what? Displacement. And so you can see that if I also use this table, I'll see that the body is also undergoing uniform velocity, because the velocity will still remain 2 meters per second. Are we together now? And so if you are to define uniform velocity, you define it as a body is said to undergo uniform velocity when it covers equal displacement in equal time interval, no matter how small the time interval may be. So this is what we mean by what? Uniform speed and uniform velocity. Now we're going to be looking at uniform acceleration as well, because this is equations of uniformly accelerated motion. So we need to understand the equations we are using and what we're using them for. All right, now uniform what? Acceleration. So in the same way, a body is said to undergo uniform acceleration if it moves with equal velocities in equal time interval, no matter how small the time interval may be. That is uniform acceleration. When a body moves with equal velocity in equal time interval, no matter how small the time interval may be. So it's just the same thing. Let us give a table showing that. Now we're going to be using velocity because acceleration is equal to change in velocity over change in time as well. Okay. All right. So velocity is in meter per seconds and time is in what? Is in seconds. And so let us just give that starting from when the body was at rest. Okay, 0 0. There was no time as well. All right. So let's now say that the body is covering let's say 4, and then these two, as it moves with velocity of 4 meters per second in 2 seconds, and then 8 in 4 seconds. Are we there? Yes. And then 12 in 6 seconds, and then 16 in 8 seconds, and of course 20 in 10 seconds. To get the acceleration is equal to change in velocity over change in time. For the first one, it's going to be what? Final velocity v, which is 4, minus initial velocity u, which is 0, over the change in time as well. That's 2 minus 0. That will give us what? 4 minus 0 is 4 over 2. That will give us 2 meter per second squared. Please take note that it must not always be 2, but it's just that I'm using an example that I'm saying, so I can as well change this. But it's not that the constant velocity or the constant acceleration must always be 2. Take note of that. So let's do another one. It's going to be what? 8 minus 4, because this is the final now, this is the initial, over this 4 minus 2. 8 minus 4 give us what? 4. 4 minus 2 give us 2. That's give us 2 meter per second squared. So the velocity is uniform. If we check for the other one, 12 minus 8 over 6 minus 4. 12 minus 8 is 4. 6 minus 4 is 2. That will give us 2 meter per second squared. And because the values of the acceleration is constant, therefore it's said to be uniform as well. And so this is what we mean by uniform acceleration. When a body is moving with equal velocities in equal time interval, then that body is said to be undergoing uniform acceleration. And I want to look at the equations for calculating parameters of the motion where a body is undergoing uniform acceleration. Are we together? All right. Now we are going to look at how to derive the equations of uniformly accelerated motion. And I want you to know that there are 3 major equations of uniformly accelerated motion. However, I'll add one more because in some textbooks they have 4, but there are 3 major ones, and in the course of deriving them, we're going to get the other one. Are we together now? Now, what I'm going to do is that I'm going to write the equation by this side so that we'll know what we are deriving. Now, the first one is v is equal to u plus at. Then the next one is s is equal to ut plus half at squared. Then we now have v squared is equal to u squared plus 2as. These are the 3 equations of motion that will make use of. However, we can add that s is equal to open bracket v plus u over 2 into t. All right. In the course of deriving these 2 equations, we're going to be getting this. Are we following now? Right. So derivation of the first equation. So this first equation is derived from the formula of acceleration. All right. Acceleration is equal to change in velocity over time, and change velocity is actually equal to the final velocity v minus initial velocity u. So it means that this is v minus u over t. Therefore, our solution is equal to v minus u over t. So we're going to use the same formula here. All right. So from A is equal to V minus U over T. Alright, we're going to make V set of formula. Make V subject of formula. Alright, make V set of formula from here. So we're going to have that this will now give us, let me bring it down again. A is equal to V minus U over T. We're going to multiply both sides by T so that we can get rid of the fraction. So we're going to have AT is equal to V minus U. And I can rewrite this as V minus U is equal to what? AT. And then I can now make V set of formula by taking this minus U over to this other side, or adding U to both sides. So I have V is equal to AT. This will come out to become plus U. However, we want to have it to look like that, and since we are adding them, addition is commutative. Are we following now? If you add two things, the arrangement does not matter. So I can write that V is equal to U plus what? AT. And this is the equation of the first equation of uniformly accelerated motion. As simple as that. You don't need to cram it. Just get it from the equation or the formula of acceleration. Make V final velocity sort of formula, and then you are able to get it. Are we together? All right. Direction of the second equation, S is equal to ut plus half at squared. Now this will be derived from the formula for distance. Okay, now I'm going to say that if an object moves and covers a distance x, a distance s, the formula for the distance it covers is actually equal to, so distance s is actually equal to average velocity. Average what? Velocities. Average velocity times time. Average velocity is also known as bar v. All right, just the same way in mathematics, you know that when we talk about average, we talk about mean. And remember, we use bar x. Okay, so bar v represents what? Average velocity. And talking about average velocity, you know that average of anything is the sum of the data given divided by the number of data. So if I'm looking at the average of 2, 3, and 5 is equal to 2 plus 3 plus 5 all over 1, 2, 3, 3. That's it. And you know that in physics we have only two kinds of velocity. We have final and initial. So the average of final and initial is actually equal to V plus U over what? 1 to the 2. So that's the formula for what? Average velocity by V. So if we substitute the value of average velocity by V, we're going to be getting our value. All right. So now I'm going to write this as S is equal to bar V times T. Now I've written that bar V is equal to V plus U over 2. That is multiplying time. So I put it in brackets times time. Are we following now? So what I now want to do is to get this formula. Now what I'm going to do now is that we are going to substitute. Let me divide this. We're going to substitute for V. So substitute for V is equal to U plus AT. All right, so wherever I see V, I'm going to put U plus AT. So I have S is equal to, open bracket, instead of this V, I'm going to put what? U plus AT, which we derive from the first formula, then plus what? U, that's the next thing coming, then everything is over 2, then open bracket T. Just in case you don't get it, this S and then equal to, then this V, I've opened the bracket, this V is equal to U plus AT from the first equation. And so instead of writing this V, I'm going to put U plus AT. What's coming next is plus, so I've run that this plus, and this is U over 2, close bracket, then this T. Are we following now? So the next thing is to rearrange this numerator, because something can actually go here. So I'm going to write this as S is equal to, inside this bracket, open bracket, this will give me what? U. I'm going to write it as U plus AT over 2 into T. Are we following now? So S is equal to U plus G is what? 2U plus what? AT all over 2 into T. Are we following now? And the next thing to do is to remove this bracket by expansion, and we can do that by using what is outside the bracket to multiply everything inside. So we have S is equal to, so this will be T times 2U. Please, whenever you are, let me say I have A over 2 times 3. Okay, whenever you're multiplying a fraction by a whole number, you are actually going to multiply the whole number by the numerator. So this can be written as actually a. I think I have to bring it down so that you can see. All right, so we have this a over 2 times 3 over 1. So end up multiplying this 3 with this whole number, and so we are going to be using this t to multiply only the numerator, okay, not the denominator. So we have what, this is t times 2, you give you 2ut, all right, plus at times t. Look at it, at times t. That will be 80 is already 80 is already a times t, then times t. T times t is t squared, so you have it as 80 squared. So you have it as what? 80 squared. That is the numerator. Are we following now? So if that is the case, we can now have this to everything is over what? 2. Are you following? Whenever you have a fraction like this, that you have the numerator separated by either plus sign or minus sign, then you can actually split the fractions. What I'm saying is that if I have a plus b over 3, this can be written as a over 3 plus b over 3, because in trying to add these fractions we get this. Remember, to add fractions, if their denominators are the same, you pick one and then add the numerators, and so we are going to work with that knowledge. Are we following now? So I'm not going to write that this is equal to 2ut over 2 plus 80 squared over 2, and that's s. So I can cancel out 2 here, and then I'll now write this as s is equal to ut now plus 80 squared over 2. Because I'm trying to have this formula to look like this, I can now write 80 squared over 2 as half 80 squared. So I have that s now is equal to ut plus half 80 squared, because half 80 squared is the same thing as half times 80 squared, and half times 80 squared coming over 1 gives us 80 squared, because 1 times 80 squared gives us 80 squared. 2 times 1 is still 2, and so this is now the formula that we actually need. S is equal to ut plus half 80 squared. We have derived the second equation of motion. All right, now we are going to derive the third equation. Remember, I've derived this in the course of deriving this one. Okay, I've derived this. Are we together now? Now I'm still going to derive this third equation, this one, from this as well. So I'm going to write that distance is equal to average velocity v plus u over 2 into time, right, times time. Now from the first equation, from v is equal to u plus at, I'm going to make t set of formula. Doing that, I'm going to move this over, because v minus u is equal to 80. All right, so I divide this by a. So it means that what, that t is equal to what, v minus u over a. So what I'm going to do now is that I'm going to substitute for t into this equation. Are we together now? So here I see x is equal to, open bracket, v plus u over 2 times, now I'm going to multiply by t. Now this is t, but t is this, open bracket again, v minus u over a, close bracket, and so s now is equal to v plus u over 2 times v minus u over a. So s is equal to, now from difference of two squares we have, I don't know whether you have learned difference of two square mathematics. If I have s squared minus y squared, this difference minus, and you have two squares, this will be equal to, just open two brackets like this, and then you have x plus y, then x minus y. So it means that if I have s plus y, s minus y, I can rewrite it as this. So now that we have v plus u, v minus u, how do you think we can write it? It's going to be what? V squared minus what? U squared. That's, I'm simplifying the numerator. Then 2 times a is equal to what? 2a. Are we following now? This is v squared minus what? U squared all over what? 2a. And so the next thing we're going to try to do now is to make this equation look like this by making v squared set of the formula, and we can do that by eliminating the fraction, that's removing this denominator here. That can only be done by multiplying both sides of the equation by 2a. And so if you multiply here by 2a, all right, so 2a will cancel out. If you multiply here by 2a, you have 2a times s, that will give you 2as. So this on this side we have only v squared minus u squared. I'll write it as v squared minus what? U squared is equal to what now? 2as. I'll now take this minus u squared over to this side, becomes positive, and that will eliminate this u squared here. So I have that v squared now is equal to 2as plus u squared. However, because addition is commutative, it does not really matter how we arrange it. I can rewrite this as now v squared is equal to u squared plus 2as, and this is the equation of uniformly accelerated motion that we need. And so these are our equations. V is equal to u plus at, s is equal to ut plus half at squared, v squared is equal to u squared plus 2as, and you can also add this, s is equal to average velocity v plus u over 2 times time. And so these are equations of motion. I'm going to be stopping here for this video. Are we together now? In the next video I'm going to be doing calculations involving jam-pass questions, wire-pass questions on this topic. Please do well to subscribe to this channel, like, share to your friends that will find it useful, because my genius science hub is for you. Are we together now? And till we meet again, bye.